Hello everyone, and welcome back. In this video, we're gonna start planning our CPU. Because even though you can just jump in and make this big, fancy CPU, you're probably not gonna end up doing it all that well. There's a lot of things that you want to know before you even start placing blocks. And if you don't know all those things, it can be really frustrating later when you have to stop and redo just huge chunks of your CPU in order to just get what you're intending to do in the first place. So it's really worth your time if you're building something as big as a CPU to just sit down and plan a few things out. When you're planning your CPU, almost without fail, the first place you want to start is choosing an instruction set. Now, of course, that begs the question, what on earth is an instruction set? And that's why I'm at my old computer, because I think the best way to sort of give an idea of what an instruction set is and why you need one is to show you a computer without an instruction set. So, first off, let's look at our old CPU. Now these are all the instructions you have, like you have the reading command, it'll read from RAM, you can select which RAM to read from, you can write, you can select which piece of RAM to write to, you can save data to the ALU, you can save RAM to the ALU, yada yada yada. You have a whole bunch of instructions. And for the most part, all these instructions have one-to-one correspondence with some wire in the processor. For example, this is I believe the subtraction command, and as you can see, it's one-to-one correspondence with the subtraction command in the ALU. And same goes for the addition command, which is down here. And the wiring's a little bit crazy, so it's a little bit weird to get in there, but you get the idea. And that's an example of not having an instruction set. You just have all the instructions that the processor can possibly do, and you're just manually controlling them. And there's nothing wrong with that, but there's a few things that are a little bit undesirable when you do that. For example, right here, I can, for example, in a single command, read something from RAM, and I could also read some information from ROM. And there's really not a situation where you want to do that. There might be this one extremely rare instance, but for the most part, you're never going to need to read from both random access memory and read-only memory at the same time, because it's just going to give you some data that's not really what either one of them is. So that can cause you a bit of an issue if you do that. And secondly, if you lay out all your commands like this, it makes programming an absolute nightmare. I don't know if you saw my video where I programmed a really simple game on this. Yeah, that game only took, I believe, 15 lines of code, and the video was 50 minutes long. And it's not hard to see why. Let's say I want to add something on this computer. Well, first off, what I'll have to do is I'll have to read my first input from RAM or ROM, but I can only choose one of them. I'll have to send the data from the RAM bus to the ALU, and then I'll have to save that as one of the inputs to the ALU. Then I'll have to repeat that whole process for input B. Now that I've loaded all the data into the ALU, I'll actually perform the addition command. And then what I'll do is I'll go to the writing command, and I'll write it to memory in some place. And after all of that is done, only then do I actually complete the addition operation. I don't know about you, but that's a lot of work just to perform a simple addition operation. And that's not really desirable. You don't want to have to go through a whole bunch of effort just to perform basic operations. Because if programming is so difficult that you really don't want to do it, that defeats the whole point of having a CPU in the first place. If you have to go through all this effort to program that you never even do it, you've wasted your time. It doesn't matter if your computer runs on a 3-tick clock. It doesn't matter that it fits in a 9x9 cube. If you can't program your computer effectively, then your CPU was a waste of your time, because it can't be realistically used for anything, because it's too hard to use. So therefore, choosing a good instruction set that's nice, easy to program, and really powerful. It's absolutely critical to getting a good CPU. Now that you hopefully understand the importance of an instruction set, I'm going to talk about what exactly they are and how you can choose a good one. So, what exactly is an instruction set? I still haven't quite answered that yet. Now, I showed you in the other computer how there's a whole bunch of built-in instructions. Like, for example, there's a whole bunch of built-in stuff where you could have explicit wires that read from memory and explicit wires that caused the ALU to save data and cause the ALU to change the operation it was using, and so forth and so on. There's a whole bunch of built-in instructions, and the way I had that set up is you could control the computer by powering wires for those built-in instructions. I also showed you how there are some instructions that you can sort of synthesize, like addition. If you want to add two numbers from any point in memory, you could synthesize those by reading data in to the ALU, reading other data into the ALU, causing the ALU to add, and saving that data to some location in memory. So what an instruction set is, then, is it's a collection of all those instructions for your computer, all the directly built into the hardware instructions, and all the synthesized instructions, and it's just a collection of all the ones that will hopefully actually be useful, and hopefully will be easy to program in the way you have it set up. So that's all an instruction set is. An instruction set is a set of all the useful instructions out of all the instructions that your computer can do. And really, that's everything I want to cover in this video. So, thank you, I hope you enjoyed, and in the next video, I'm going to start talking about how you can choose a good instruction set, and choose the instruction set that's really the best for whatever CPU you're designing. So, thank you, and I will see you next time.